In today's class, we're going to talk about directory or path traversal. Now, we already covered broken access control vulnerabilities previously, and we said that 94% of websites, according to OWASP 10, are vulnerable to these vulnerabilities. So if you're doing bug hunting or pen testing, then your chances of finding these vulnerabilities are really, really high. And we said in the previous class when we spoke about broken access control, the definition of it is that they allow us to access or modify information beyond our limits. That's the main thing. That is the definition. So if you find any bug that allows you to modify information beyond your limits, then it falls under broken access control. As you can see, the term is very broad, and a lot of other subcategories or sub-bugs or vulnerabilities can fall under this category. And an example of that is directory or path traversal. So the idea of these bugs or vulnerabilities, they basically allow you to access paths or locations on the target web server that you're not allowed to access. So we said broken access control allow you to access or modify information beyond your limits. And directory or path traversal allow you to access paths or files that are beyond your limits that you're not supposed to access or see. So zooming in on a file system in Linux, basically you have the /, literally just a / with no text after it. That is your root or base directory in your file system. And then inside that, you would have a number of directories. For example, you would have var, you would have home, where you have the user data. You would have etc, where you would have the configuration files for the various programs installed on the system. And you would have obviously a lot of other directories. And then within them, you can have other subdirectories. And you can even create your own directories. We've all seen that and we've all done that. Now, when you install a web server on a server or a computer, you basically define a certain path where the website files will be stored. So that path is usually var www, and sometimes you would have HTML in it, sometimes you would have the username in here somewhere. But the main idea is you would define a path within your file system so that it contains the files of the website, and when users access the website, they get served files that are included in that directory. So this directory would be called a web root. It can actually be anywhere. It doesn't have to be in this path, but this is one of the default paths where the web root is. So this path will contain the website files, and when someone accesses your website, for example, zaid.com or zsecurity.com, the files included in this directory will be served to the user. Now, directory or path traversal vulnerabilities allow us to break out of this path and load files from other locations on the server. Or maybe even load files within this server, but you're not allowed to see. So maybe load source code or sensitive files that are not directly visible through the URL bar, through basically just putting the website location. So let's go ahead with a simple example. We have a normal website as usual, and you should test every single functionality as usual, as I say. But we're gonna go ahead and load a product because I know that is what's vulnerable within the website. And as you can see, you get a product image, the description, and a back button. And as usual, you want to test everything, whatever parameters you have in the URL and all of that. And as usual, we usually look at the normal behavior of the website before we break it. And then we would turn on our interceptor, load the website again, and start analyzing the data that is being sent. So we can see we have a product ID parameter number 3. Again, that should be tested, but I'm going to skip it now because that's not the vulnerability that I want to show you. So I'm going to forward. And the next request that is being sent is the one that I want to focus on because that is the vulnerable one. As usual, you can modify the data in here by modifying anything that comes after the equal signs, as we said before, or you could just filter it here using the request attributes and the request parameters and double click in here and modify the data. So I prefer to do it here directly in plain text. And if you look in here, you'll notice that you have a request that is being sent to an endpoint called image. the parameter is called file name, and you can actually see a proper file name after it with an image extension. So we have 5.jpg. So straight away, when you see this, I would send it to my repeater so I can send these requests and play with them easily without having to always hit enter here and then analyze it here. Turn off my interceptor, we go to the repeater, and again we send the normal request before we play with it. And if we render, you can see we actually got the image. So this is probably an image that is called 5.jpg, because this request is requesting something from an endpoint that is called image, and it's passing a value that is 5.jpg to the parameter that is called file name. So we can guess that we have an image that is called 5.jpg on the target web server stored somewhere within the file system, probably in a directory called images. That's just a guess, maybe not, it doesn't really matter. But we have the image and it's called 5.jpg and it's being loaded in here. Now that's still just a hypothesis, we're not sure that this is correct. So what I would do at this stage, before I try to exploit this or get information from the server or access information that I'm not supposed to access, before I do any of that, as I always say, I try to keep everything as simple as possible when I'm testing and then add up to my exploit or to my bug so that if anything fails, I know what failed and then I can fix it. So before I try to exploit anything, I'm gonna go back to the home page. I'm just gonna load any other product, and we have an image in here, so I'm gonna open it in a new tab, and we can see the file name of this image is 31.jpg. So I'm gonna come back here, and instead of loading 5, I just wanna see if I can actually just load another image from the server by simply giving the image name. So we put 31.jpg in here, we're gonna send. And perfect, as you can see, we actually managed to load this image. So basically we're able to access files still within our web root. But that is really good. That's one step towards our goal. The next step is to try to load a file on the target system, but that is outside my web root. So somewhere from home or etc or anywhere else within the server. Now, the best way of doing this is to load a file that exists by default on the target system. So the files in home might vary depending on the username and depending on what the user wants to store in their home directory. But there are configuration files that exist on every Linux computer, and therefore we know for a fact that it exists on the target. So if we load it and it actually loads for us in here, we will know that we are able to access data beyond our limits, and therefore we have discovered a broken access control vulnerability. And because it's allowing us to load files or paths within the target server outside of the web root, then it is a path or a directory traversal vulnerability. Now, there's a lot of default files in Linux that you could load. One of them is etc password. So let me just show you before I load it in here. I have a Linux computer in here, a Ubuntu machine. And I'm simply just going to go to my file manager. I just want to show you that file just so that it's clear to you. And I'm going to go to my path bar and I'm simply going to go to etc. And if I just type passwd, you'll see that I have a file called password. And if I double click this file, I'll have the users registered on this server. So we're going to come back in here and we're simply going to try to load that file. So we're going to replace this 31.jpg with the full path where etc password is stored. And therefore, I'm not really guessing anything with this. I'm just putting a file name that exists on all servers, and if it loads, then the target is vulnerable. So I'm going to hit enter. And as you can see in the render, we're going to get nothing because it's actually just a text file. It's not an image. So if we go on the raw, you will see we are able to access the contents of this file, and we can see all of the users registered on the target system. So not only that, this is a massive information disclosure. In a bug bounty scenario, this is enough to display impact. So literally being able to load this file or any other file outside of the web root is enough to display impact, and therefore you should be awarded a bounty for this finding.